Hi, I'm going to solve quiz 2 for week 5 that says like follows. The figure shows a mass M2 of 20 grams resting on top of a mass 1 that is equal to 20 grams, which is attached to a spring with a constant equal to 10 newtons over meter. The coefficient of static friction between the two masses is 0.6. The masses are oscillating with simple harmonic motion on the frictionless surface. What is the maximum amplitude the oscillation can have without M2, that is the one up top, flipping of mass 1? For solving this problem, we have first to create a diagram from the mass 2 in order to calculate how much is the amplitude before this mass falls from mass 1. So the diagram will be drawn like this. Here is the mass 2, and here we have the mass 2 times gravity, but also we have here the friction, that it's mu s and 2 gravity. The friction goes this way because the mass, the spring is pulling the masses to the left. So the friction is the opposite way towards the movement. We also know that the acceleration is going this way because as we see, as the block 1 is moving to the left, the block 2 it's falling for this side because the movement it's pulling the block towards the opposite direction. Once we know our diagram, we can see that for calculating the amplitude, we need the angular velocity that it's obtained for the acceleration. The maximum acceleration will be equal to omega squared times the amplitude. We also know that our omega will be equal to the constant over the mass. But here we have to use the total mass of the system in order to calculate exactly the movement of both objects. Once we have this, we can say that this will be mass 1 plus mass 2. Then we can calculate this with the Newton's second law that says the maximum force will be equal to the mass times the acceleration. And here we are only talking about the second mass because this one is the only one that will be falling or moving besides the movement of the strings. Once we know this equation, we can substitute here the value that we obtain, and we know that the acceleration is equal to this one. So we substitute here, and by calculating this one, we know that this one is equal to this one. So we can rewrite that mass 2 from here times the acceleration, that this one is this one, but as it's squared, the square root is cancelled, so we will have that constant over both masses, because we said that it's the whole system, times the amplitude. Okay? And we also know that by seeing our diagram that we only have one force that is moving in the x-axis. So we also know that our maximum force in this direction will be the friction. So it's mu s times the mass times the gravity. So once we have these two equations, we can put them together and set that the mass 2, that is this one, times the constant over mass 1 plus mass 2 will be, and here we're missing the amplitude, will be equal to the mass, to the mu s times mass 2 times the gravity. And as we can see here, we have mass 2 in both sides, so we can cancel it. And we now can get the A out of the equation, and we will have that the amplitude will be equal to mu s times gravity times the total mass over the constant. And as we substitute our values that we have, we know that mu s, that it's given in the problem, it's equal to 0.6 times the gravity times the mass 1, but we are writing it here in kilograms because it is given in grams and both have the same mass. And all these will be over the constant that it said in the problem that it's equal to 10. Once we solve the equation for the amplitude, we will obtain that the amplitude will be equal to 0.02354 meters. That will be the same as 2.35 centimeters. And this is how you solve a problem of finding the amplitude.